Howdy everyone, Nir Regev here, and today we're going to cover the paper Human Identification based on radar micro-Doppler signatures of separation. This is a nice work. It's really a proof of concept that is showing how to use a radar to distinguish between several people, to tell this is Nir, this is Joe, this is Jen, and so on and so forth. So they propose this experimental setup. This experimental in figure 1 is the radar is covering a hole, and the person or persons are traversing the hole back and forth. So basically it's a method for human identification using deep convolutional neural network, namely AlexNet, 5-layer network. And the input to the network is radar micro-Doppler images, like we see here in figure 2. Okay, when a person walks, their limbs and torso and basically their gait is captured by what we call the micro-Doppler phenomenon, which is a phase or frequency modulation on the returning wave. And if we plot a spectrogram, which is basically a short-time Fourier transform, we can see a signature for each and every human. Now, how best to distinguish between these signatures? It's very hard to the naked eye, but a neural network can actually do it. They start by explaining that radar micro-Doppler is used to detect the unique signature that is caused by human movements, like I just said. And despite its utility, little research has been focusing on identifying individuals based on these signature. Now that is not entirely true. This kind of work has started a long time ago, not with deep learning, but started a long time ago, and identifying humans with the radar. I actually, through my company Aleph Zero, have been engaged in several projects in which a human has to be identified and classified. Okay, so this is not entirely new. That it's very new. It's not new. Okay, the data collection, they proposed a 5.8 gigahertz radar with vertical polarization and a sampling rate of 12.8 kilohertz. The setup captures walking motions from 10 subjects in an open corridor, like we've seen in the image, with their micro-Doppler spectrograms processed using the short-time Fourier transform. Differences in the spectrograms, particularly in the limbs, micro-Doppler signals highlight their inter-subject variation, like they call it. Okay, they also employ a algorithm that is based on the short-time fractional Fourier transform, coupled with what they call morphological component analysis, and they separate between the torso and the limbs movement. And they say that this metric here, what is called the Bhattacharya coefficient, is suggesting that the bulk translation or the torso movement is not essential for classification. It's actually just nuisance, so they remove it. Okay, they separate it, and here they show their confusion matrix, and they achieve that approximately 90% accuracy. Now they do group size comparison. They achieve on 4 people 97.5, up to 8 people 91.25 accuracy, which drops to just below 90 for 10 people. Okay, this is actually 89.75% accuracy. And so this is a short paper, like a letter, and this is something, by the way, that I teach in my course, AI in radar signal processing. My students are given both examples and as well as projects to do with this kind of project specifically for human classification. And that's it for today. So feel free to subscribe and like if you like the content. Also, please follow me on LinkedIn, Instagram, and Twitter. Thank you very much for listening, and see you next time.